Hi everyone. So we are back on checker. No, not yet checker understanding 1.5 on page 48. So this is powers with negative rational exponents. We will try to develop an understanding of powers with negative rational exponents. Is something that you are not or you may have not done before, but having gone through sections 1.1 up to 1.4, you would see that, oh, the way to do 1.5 and 1.6 would really be similar. You just need to use more of what you have seen before, if that makes sense. All right, let's take a look. Um, to get started, to be able to develop an understanding of powers with negative rational exponents, let's begin with evaluating these powers. Guys, we talked about this before. When you have a negative exponent, all right, what does it mean? Well, what it means is that if you were to begin with 5 cubed, that is 5 times 5 times 5, right? And 5 squared is equal to 5 times 5. And as you can see, each time I am subtracting 1 from the exponent, you are dividing by 5, right? I don't know if you understand that. And let's take a look one more. Okay. 5 to the 1 1, not because it's what the teacher said, but because you can actually show the math behind it. You again divided by the base, okay? And then let's just continue, finish this up. Therefore, if it was 5 to the negative 1, it would have been to divide 1 by 5, which is, okay, instead of writing 0.2, I will write 1 over 5 so that I can see the pattern here, all right? And that tells me 5 to the negative 2 would be to divide the previous expression again by 5, which gives me 1 over 5 squared, which becomes 1 over 25. And again, the pattern here is that when you have a negative exponent like here, when I had 5 to the negative 2, if I compare it to 5 squared, the only difference is that 5 to the negative 2 has a negative exponent. What happens to the value? 5 squared becomes 25. 5 to the negative 2 becomes 1 over 25. So really, you just make it 1 over, all right? Or some people refer to it more properly as the reciprocal. Okay. What about this one? So this one, if you use your calculator, all right, so you can actually see that the value would be what? It's going to be 64. Now, if you're thinking, how do you do that? Well, we have seen it before. We're in the cube it also, or cube it first before getting the square root. Now, I don't know which one you want. Both of them would work. So let's take a look. If we do the first one, so the square root of 16 is going to be a 4. All right. If we work from the inside to the outside using BEDMAS, and 4 cubed would be 64. Okay. Well, this one, if you do it this way, if you get the cube of 16 first, that would have been 4096. And the cube root, and the square root rather, of 4096 is 64. So again, it's the same answer depending on how you want it done. All right, it really would remain the same. So I'd like you to consider something here as we work with a power with a negative integer exponent and the rational base later on. Let's just talk about what is the square root of 100? All right, that would be 10, right? And remember that square root of 100 can also be written as 100 to the 1 half, isn't it? All right, now I want you to think about what about if I come up with another expression using this one, but this time with a negative exponent. Let's take a look. All right, 100 to the negative 1 half. If you are to use a calculator, you will see that the answer is 1 over 10. Now, if you're thinking, okay, where did that come from? Now, we know that when you have a negative exponent, it is going to be 1 over the expression, right? So another way of writing this would be to make it 1 over 100 to the 1 half. So if that is sort of unclear, stop this or pause this video for a bit and think about what I just did so that you can have a better understanding of it. So to recap, all I did was I rewrote this expression with a positive exponent by making it 1 over. All right. So the moment you put a 1 as a numerator, and then this becomes a denominator, but the exponent is now positive, then you have just rewritten it with a positive exponent. And now what is 100 to the 1 half? Well, another way to write it is this one, isn't it? And so there you have it, 1 over 10. Okay. So that is one way to do it. Now, if you're thinking, how does that relate to this one? It's really the same thing. Okay. So, so if we go back to the idea of like 5 squared, 5 to the negative 2, blah, blah, blah. Remember this, what I did here. In the previous screen, if you want, you can actually rewind. I came up with something like this. 5 to the negative 2 equals 1 over 25, right? Like this. So really, if you're thinking, where did that come from again? Well, it's 1 over 5 squared. That's where it came from, right? When you have a negative exponent, you can make the expression have a positive exponent by giving it a numerator of 1. Now, in here, in this concept, what it is saying is, if it was a fraction that you have, how will it look like? So the idea is going to be the same. Take a look at what I'm going to do. It says here you have a to the a over b. So let's come up with a fraction here. I don't know, maybe 3/4. All right. And then let's say you have a negative exponent m, and our negative exponent would be negative 2, just saying, okay? According to this, all you have to do is get the reciprocal of a or b, a over b, which makes it b over a, and then the negative exponent now becomes a positive exponent. Now you're like, huh? How does that work? All right. This is how it works. Well, just keep this in mind for now, right? And once again, I'm going to show you how this works using the pattern with positive exponents. All right, so keep that in mind for now. Let's begin with 3/4 squared. What would that be? That would be 3/4 times 3/4, 9 over 4. What is 3 over 4 to the 1? Which is just 3/4, right? You write it one time. But how do you get this from the previous expression? Well, guys, when I subtracted 1 from the exponent, what did I do? Just like in the previous screen, I divided by the base, isn't it? Okay. Therefore, 3/4 to the 0, oops, is to divide by the base again. That's why it's a 1. And you can see that 3/4 divided by itself is a 1. Okay? Now, what about 3/4 to the negative 1? What happens now? Well, what's going to be happening is you are going to be dividing the 1 by 3/4. All right? Now, I'll just go straight into the math behind it. There is a visual representation for it, but that would take a lot of time. I don't want to do that right now. Probably I'll do that in class. So how does this work? 1 divided by 3/4. All right. 1 divided by 3/4. All right. According to what you have learned in elementary and which was also shown in grade 8, when you are dividing by a fraction, you copy the original number or the one you're dividing, and then you flip the second, or you flip the fraction, the second fraction, and then you turn it into multiplication. There's your answer. Okay. Notice what happened to the number 3/4. 3/4 to the negative 2. So that would be to divide this value by 3/4 again. Yep. Okay. Never thinking. Okay. That's sort of um, complicated. Let's take a look. So we have 4/3, which is the value here before we divide by 3/4, divided by 3/4. Yeah. Because by writing it this way, you will see now why the concept works. The one that was introduced at the very beginning. 3/4 became 4/3. It was um, let's do one or maybe a couple. Um, I would stop at the 15-minute mark because I don't want to take too long. And at any time, if you feel like you should have stopped, then that's okay. Evaluate the power. How does this work? So if you have a negative exponent, that just becomes 1 over 7 squared. And to evaluate is to find the final value, 1 over 49. Okay. What about this one? Evaluate negative 2 to the negative 4. That would be having your negative 2 as your base. That would be 1 over negative 2 to the 4th. And negative 2 times itself 4 times would be 16. Okay, there's your answer. Negative 0.2 to the negative 3. Well, there's different ways to do this, but me, what I would do here is turn the 0.2 into a fraction, okay, which makes it easier. Why? If you do this, then you just use what we saw in the previous screen, wherein if you have a fraction and you have a negative exponent, you flip it over, right? So it now becomes 5 over 1. And then you can turn this exponent now into positive, which makes it 125 over 1 or 125 only. All right, and the last one, if you have this, flip it over, 15 over 18, and then square it to 25 over, okay, 324. Now guys, you will notice that the answer is 6. Mr. Aaron, can could it would it have been easier if I simplified this first right at the beginning? Oh yeah, for sure. So just to finish this off, 18 over 15 to the negative 2. If you cancel the top and the bottom by 6, all right, so divide by 6 is a 3, divide by, no, not divide by 6, divided by 3 is what I meant, because the answer is 6, okay. So divided by 3, this is 6, divided by 3, this is 5, okay. And this one would be 6 over 5 to the negative 2, which is 5 over 6 to the negative to the positive 2, which is 25 over 36. Okay, that's it for now. So take a break. I'll see you in check your understanding number 2. Thanks. Bye.